Good afternoon. I'm Stephen Clark, editor of Spaceflight Now. Thanks for joining us for another news roundtable. We're joined today by Caleb Henry, the director of research for Quilty Analytics, also a former space reporter from Space News, and also joined by Bill Harwood, the space consultant for CBS News. We want to take this chance to thank our subscribers on YouTube and thank our supporters on YouTube as well. Who join us for our launch coverage. And this event, though, we're going to recap some recent news in the world of spaceflight. It's been a very busy few weeks with launches here at Cape Canaveral, as well as the recent completion of the first generation internet constellation of OneWeb. First of all, we want to recap some of the freshest news we have. Yesterday, we had a launch here at Cape Canaveral of 56 more Starlink internet satellites aboard a Falcon 9 rocket. This launch was occurred at 4:01 p.m. Eastern Time, 8:01 UTC, and deployed 56 more Starlink internet satellites into orbit. This was SpaceX's 21st launch of the year, pushes the total number of SpaceX launches so far for the Starlink network to 79, and more than 4,200 Starlink satellites now have been deployed in the network. Caleb, your expertise, I think, is in commercial space as well as in communications. That's right in your bailiwick with the Starlink network coming online more and more with each launch. Can you kind of update us on where the company is in as they roll out operations?
Sure. So Starlink is really interesting in how fast they've been able to deploy this network. Like you said, some over 4,000 satellites launched, of which I can't remember. I think there's a few hundred less than that are in service because they roll off the older versions or those that have anomalies and refresh them with newer ones. So right now, Starlink has just about or is getting close to completing their first generation filing with the Federal Communications Commission. That was for approximately 4,400 satellites. And after that, they will expand into their second filing, which is for 7,500 satellites. And we've seen them already start to introduce their V2 Mini, even though the first batch suffered some anomalies it's coming back down. But Starlink, interestingly enough, two big changes. One to be celebrated, and one is just more so growing pains. It looks like at this point, Starlink has become, in terms of subscriber count, the number one satellite internet provider in the world in terms of consumers. They haven't published an exact figure, but if you kind of plot their growth in subscriber numbers, they hit about 1 million subscribers at the end of last year. And then a few months prior to that, they were at 700,000. So for all intents and purposes, they're likely around 1.3 million consumer subscribers for Starlink today, which would just put them past Fuse network system, which had 1.2, 1.27. So we've been following that pretty closely here because the consumer internet business is a hard one. It's gotten a lot of attention these days because of the notoriety of the names that have gotten into it. But the truth of the matter is there's been very few players that have made a serious push into it. And the only ones that have were principally focused on the US, to a lesser extent, Europe. So now we're seeing significant growth in terms of what Starlink is doing in reaching consumers and gradually reaching other customer sets, whether those are governments or businesses, airlines. And it'll be really curious to see going forward how they expand internationally. That's always been a hard part, a difficult part of the business for satellite operators. But with a global LEO network, it's certainly something that they intend to do.
And correct me if I'm wrong, Caleb, but each one of these launches adds more capacity to the network so they can have the technical capacity to bring on more subscribers. And then
Mhm.
at the same time, they're working the regulatory side to get approvals in all these various territories and nations, right?
They are, yes. So one of the things that we've started to see, you can see it percolating a little bit on forums like Reddit, but Starlink has run into a little bit of capacity constraints in densely populated or maybe not densely populated, but areas with denser clusterings of their customers. And this is actually the same pattern that you see for companies like Hughes and Viasat, the two incumbent operators of geostationary satellites. They would launch a geostationary satellite and they would use it for a few years, and then eventually the network would start to get full, and then you get network congestion, you get a limited supply of capacity. Then they've got to build a new satellite and increase their supply. So one of the things that's novel about LEO networks like Starlink and future Kuiper is that they can keep scaling as they deploy service. The first goal is to get global coverage, and then you can do what's called densifying your network. You keep adding more satellites, you keep layering on more capacity. And so Starlink has hit that point where they're finding areas of network congestion where capacity is pretty intensely used up, and they're seeking to add more satellites to provide more room for growth. Some of that growth or that the strain that's causing them to run short of capacity in various areas. It's certainly the rapid pace at which they have added subscribers, but it's also just the general clip at which data consumption goes up. The space industry, the satellite communications industry in particular, is not historically been very good at moving at the speed of other technologies on Earth. Geostationary satellites tend to last 15 years or even longer. Um, so what's happening with Starlink and these new systems is you're putting in satellites that have much shorter lifespans, and can scale much more quickly. And it's just a new way of doing business here. So we're seeing now whether or not these new LEO systems can actually stay ahead of the demand, both from new customers and just the fact that every year people need a little more bandwidth than they did the year prior.
Bill, this was the 21st launch for SpaceX of the year, and earlier this morning, SpaceX tried to go for their 22nd launch of the year, but there was a very rare last-second abort, I think at T-minus 3 seconds out at Vandenberg Space Force Base, where a Falcon 9 was set to go with the first batch of satellites for the U.S. Military Space Development Agency, which is developing its own large constellation of hundreds of satellites for a data relay and missile tracking, sort of a next generation mesh network that will be deployed in low Earth orbit. Bill, can you talk to us about the pace of SpaceX missions this year and just how busy are they?
It's really hard to even talk about it because it's never happened before. We've never seen an American company launching rockets at a pace anywhere near this. And it's interesting. There's such a following of SpaceX out there in social media and elsewhere in the public. There's a lot of obvious charisma around Elon Musk, the founder and chief designer, but also just what they've achieved with this enormous flight rate and putting the Starlinks into orbit, as Caleb was talking about. I think one thing that has to go along with a flight rate like this, you mentioned the abort at T-minus 3 seconds. That's not unusual at all in any rocket system, but when you're launching this many, failures are going to happen. And I'm not sure everybody realizes that. SpaceX has a great record. Going into this, they've only had one in-flight failure. They had one more on a launch pad. These were several years ago, but I mean, it's going to happen. It's not a matter of if, it's a matter of when. And people have to be prepared for that. But that said, I mean, all you can do is look at their track record, and they seem to have the procedures in place to. I won't say they make countdowns and launches routine because no space flight, by definition, is ever routine. But they seem to have this down pretty well close to a science, if you will. And it's really going to be interesting to see how they get through this year with, as you say, 100 launches on tap.
Yeah, and they've racked up quite a record. I think they're approaching the point where they'll reach the 200 consecutive successful flight mark probably in the next few months. So launching once every 4 days on average to start the year is quite a blistering pace, and it's a challenge to keep up trying to cover it. Caleb, another launch we saw over the weekend was in India at the Satish Dhawan Space Center. You were there for the launch of 36 OneWeb internet satellites. Can you talk to us about the significance of this particular launch for OneWeb, which has a similar but distinct network and a distinct business plan that's separate from Starlink? Kind of the differences between those two and what this milestone launch meant for OneWeb.
Sure. Yeah. So I'll tackle first the significance of this launch and then go into some of the network differences. But this launch was really important for OneWeb because it essentially completes their constellation. So OneWeb needed 588 satellites to achieve global coverage, and they were just a few shy of that. So they've been launching them in batches of roughly 32 to 36 satellites at a launch. This launch carried 36 and pushes them to, I believe the number is 618. So it enables them to have global coverage and then gives them some redundancy in their network. And I believe they have one more Falcon 9 mission that will be a shared mission that will include a select number of additional spares. But for OneWeb, achieving global coverage has been a long sought after goal. It's still going to take them a little more time because the satellites need to drift to their orbit, and they have a higher orbit than what Starlink has. Starlink is at about 550 kilometers, whereas OneWeb is at 1,200 kilometers. So it's more than twice as high, which helps explain why there are fewer satellites in the OneWeb network. You know, the further away you are from the Earth, the fewer satellites you need to cover the entire surface of the globe. But they'll take until the drifting will take 3 to 6 months, depending on their orbital plane. And then they'll actually achieve their global service. So that's something that I think is anticipated late this year, maybe early next year, depending on whatever milestones they have in terms of software updates, ground segment deployment, things like that. OneWeb has also been focused much more on, I call it, enterprise business. They're less focused on the consumer. So there is not at this stage a user terminal like what Starlink has or what Amazon Kuiper unveiled earlier this month that the average person can go and buy and just put on their house. For internet, OneWeb is focused on connecting businesses, connecting governments, connecting ships and planes. And while I was there, in India, I was talking to a number of the customers there who explained some really interesting use cases for how they're going to use OneWeb. For example, there was a company that provides connectivity in the country of Gabon in Africa, and they described trying to provide service in kind of the valleys of some of the mountainous areas. They said it's so mountainous that geostationary satellites often can't beam signals into the valley. But because you've got a LEO network where they're constantly crossing, you get better coverage, so they can actually provide connectivity. There's another company that has cell phone networks or cell phone towers, and is very interested in using OneWeb service to backhaul data from those towers, so they don't have to build fiber, or if there's a fiber cut, they may not have to stress about it as much because they can just connect those towers over the OneWeb satellite network. So lots of interesting use cases that are emerging there, and they have sought to differentiate themselves from Starlink in that regard.
And it's been a long road for OneWeb. They've overcome a lot of hurdles on the way to getting to this point. Caleb, can you talk about some of the challenges they've had to hurdle, so to speak, on the way to get to full global coverage?
Oh yeah, well, the biggest one, which is probably most relevant for the audience here, was just their launch snafu, in terms of what happened with Russia. How Russia, when they invaded Ukraine, actually chose to hold OneWeb's satellites hostage at the Baikonur Cosmodrome in Kazakhstan. And so a batch of around 36 satellites essentially stolen there, as well as the payments for 6 more Soyuz launches, and that forced OneWeb to have to look elsewhere at a time where it's really hard to find new rockets. Everybody, all of your established launch providers are in the process of winding down legacy vehicles and spinning up new next generation launches, with the notable exceptions of SpaceX and India. So those are the players that they had to go to. They chose the Falcon 9 to step in and replace Soyuz, and then through their connections to India, through Bharti, their one of their largest shareholders, they were able to get access to the GSLV. And this was notable because the GSLV had not flown commercially before. It was a rocket that I forget the exact number of flights it's done now. I want to say it's around 6 or 7, but had only been used for demonstration missions or for science missions or projects of the Indian Space Agency, ISRO. Here, by necessity and having good contacts and a good network of partners, they were able to tap into what ISRO had at hand and get their network up still this year without incurring an extensive delay.
Caleb, you were at the launch on Sunday Indian time. What were your impressions of visiting the spaceport there in India? I know a lot of Americans don't get to visit.
Yeah, so as far as I could tell, I think I was the only American that was there. Um, Everybody that I spoke to was either from India or from the UK, not surprising given shareholder and company headquarters locations. Um, and then they also had a number of their customers that were across Africa and Asia and elsewhere. Um, it's hard to compare, and I might be actually a strange person to ask this because even though I am an American, I've actually never attended a launch at an American spaceport. I've been to Baikonur, I've been to Peru and French Guiana, and now I've been to Sriharikota in India. But I don't really know how to compare it to an American launch. So uh, what what to say? The transport, the trip is about a 3-hour drive from the nearest big city of Chennai. While you drive out there, you're going to see lots of cows on the roads, uh, lots of people everywhere. Kind of India's vibrant and growing economy is on full display. Um, Sriharikota is an island. It's warm, sandy, a little bit of what you'd expect, and also some wetlands. I did get a good chance to go up and see the rocket, and it looks very impressive. You can see the whole array, the lightning rods around it, and just all the preparation that went into it. It was fun seeing the whole banner of flags from every nation that's represented because OneWeb has so many investors from around the world. So you've got the UK flag, you've got the British flag, you've got the Japanese flag, French flag. I think South Korea's flag was on there. But truly, it was a special launch, and less so the trying to describe the actual look and feel of the place. I would say that the atmosphere was one of significance. I think there was an air of relief for OneWeb because of this long journey that they've had. We mentioned the launch saga that they had, having to replace a lot of their vehicles. OneWeb also went through Chapter 11 bankruptcy protection back in 2020. That was a hard time. And they had to kind of trailblaze with a number of firsts in terms of scaling up for mass manufacturing and getting landing rights in various countries, similar to what Starlink and others are trying to do now. So there's just been so much pushing and effort to get to this point that I think for OneWeb, there's a great deal of satisfaction in finally seeing the network come to completion. And there was enthusiasm on the part of ISRO because they've proven that the GSLV can be a commercially viable vehicle. And that's really important at a time where, as mentioned, so many vehicles are offline, and there's 2 Ariane 5s left. The majority of the Atlas 5 has been purchased by Kuiper. And so for players that are looking for a vehicle that's in production, that is steady. If India can step up to the plate in terms of production and processes, they do have a meaningful opportunity in front of them, certainly for the next 3-4 years.
And OneWeb is not done. They're in the process, I think, of merging with Eutelsat and planning a second generation constellation, Caleb. And I guess Indian rockets, given the partial Indian ownership of OneWeb, could play a role in that too.
Yeah. So the folks at ISRO and at New Space India did not waste time mentioning the fact that they are ready and willing to serve OneWeb in the launch of their Gen 2 network. So one of the challenges, because it's taken OneWeb as long as it has to launch their satellites, the spacecraft were designed for about a 5-year lifespan. And they started launching in 2019. And even though there was a little gap between the first launch and then the eventual, steady launch campaign, it still leaves them only a little bit of time between now and when they actually have to start deploying the second generation. Also, during that time, technology has evolved quite significantly, as well as the market. So it gives them some opportunities to do some new things. For example, with Gen 1, they were very much looking at Russia as a possible market. It's a large country, lots of rural areas that aren't going to be connected by fiber or cellular. There's a great chance for satellite connectivity to get involved. The geopolitical landscape has since changed. I wouldn't be surprised if they were at one point looking at China as a market, given their decision to exclude optical, laser crosslinks between the satellites, and that was part of providing, data security to governments. Sometimes they want the digital traffic to land in their country and remain only in their country. But with Gen 2, they get a chance to create a network that is more nimble. Should they choose, they can add crosslinks, which really allow you to speed up your network and deliver bandwidth much more flexibly. There's also really significant advances in terms of phased array antennas. I think we've seen this a lot again with Starlink and Kuiper and some of the new players that are producing these antennas for people to use on the ground. But there are more advanced versions of the same technology that are being used on satellites, and that enables you to shape the beams in terms of your size, the shape of your beam, power of the beam, and where it's pointed in a way that allows the spacecraft to be much more responsive to customer demand. And so in some ways, this gives a chance for OneWeb to overcome the risk of technology obsolescence. As their competitors put up new advanced networks, they don't have to wait that long. Again, they don't have to wait 15 years like a traditional geo model. They can go and start moving faster. That does come with a cost. I believe the estimated price tag for Gen 2 right now is around $4 billion or euros. So it's a non-trivial amount of money. But they do anticipate issuing an RFP this year. And I think that they could have satellites on order by the end of this year. If not the end of this year, probably next year. I'm sure there's some pacing items in terms of getting their Gen 1 network online, completing the merger with Eutelsat, and just the competition, which frankly is one that I expect to be pretty fierce. Eutelsat is a strong proponent of French businesses. You can look at their buying practices, and they're very much a buy European and buy French company when they can. You've got this stake by the UK government, and there certainly was anticipation that manufacturing would move to the UK as a result of that. ISRO, which is angling for launches, I would not be surprised if India also tried to offer some sort of manufacturing expertise. And then you've got a whole slew of companies. I still think that the US is a powerhouse of satellite manufacturing, with more manufacturers here than anywhere else in the world. And those are also going to compete and offer very competitive services. So we'll see what they choose. It's going to be a really dynamic bid. And companies that are vying for business with mega constellations know that these are really lucrative opportunities. So I would expect a lot of players to throw their hat in the ring.
Yeah, and OneWeb, of course, is up against two players with very deep pockets with SpaceX and Amazon. So it'll be interesting to see how that evolves as they plan their Gen 2 network. Moving on, if you're just joining us, I want to say we're joined by Caleb Henry, the Director of Research at Quilty Analytics. Also, he's a former space reporter. And we're also joined by Bill Harwood, the space consultant at CBS News. The next thing we wanted to talk about was the first launch of the 3D printed rocket from Relativity Space, which occurred back in, I guess, last week from here at Cape Canaveral, Florida. The Terran 1 rocket was aiming to become the first 3D printed rocket to reach orbit, also had a chance to become the first methane fueled rocket to reach orbit. It did have a successful stage 1 flight. However, there was a problem that the company encountered when they lit the upper stage engine about 2.5 minutes after the flight. That upper stage failed to develop full thrust, and the rocket fell back into the Atlantic Ocean. This was a test flight, so not entirely unexpected. And in fact, Relativity seems pretty pleased with the results of this flight. Bill, you were here for the launch. You saw this thing take off, head into space. What were your impressions?
Well, it's interesting. I would probably be one of those who would put this in the category of a successful failure. As you know, the first stage did perform apparently properly, and the second stage engine didn't ignite. But that's still a major achievement for the company. I mean, rockets are flying differential equations. They're getting lighter as they consume their propellants. They're accelerating like a bat. And as they climb out of that dense lower atmosphere, there's a lot of stress on the vehicle. And as the company said all along, getting past that region of maximum stress, max Q as the aerodynamicists call it, was a major milestone. And the stage apparently did that very successfully. Whatever stopped the second stage engine from firing, I'm sure they've got telemetry that will help them pin that down. And hopefully they'll get back on the launch pad again soon, and we'll see this rocket fly again. But I think it was an impressive first step. You mentioned the fact that most of the components, 80% of this rocket, they say, was 3D printed. Pardon me for that, including major components of the engines. And like I said, getting that kind of rocket through max Q was an achievement, but we're going to have to wait a while to see them chalk up a success, clearly.
And Bill, watching the launch, just visually, one thing that stood out was the very, very brilliant blue flame of the engine.
Oh, yeah.
Seeing the orange that produced by kerosene engines or solid engines. This had a very different look, right, Bill?
Yeah, it really did. We were watching across the Banana River, about 7.5 miles from the launch pad, I guess, about as close as we could get anyway. It was very, very different looking. Of course, it was a night launch, brilliant bluish white flame from the first stage engines. If you've seen some of the close-up photography, some of the photographers have captured with remote cameras, I mean, it really is spectacular, and it's strikingly different from what we're used to seeing with a kerosene burning engine like the Falcon 9. Or even hydrogen oxygen engines like Artemis space launch system. So really a very surprisingly spectacular launch for a relatively small rocket.
And the company Relativity Space is already working on a new rocket, a much larger rocket called the Terran R, which is supposed to be fully reusable. And depending on how the results of this investigation into what may have gone wrong during the test flight finds, there's a chance that Relativity may be one and done with the Terran 1 and may move straight on to the Terran R and launch this much larger, twice the size, nearly 20 times the payload capacity of the Terran 1. Caleb, we've seen SpaceX become a juggernaut in the space industry, in the launch industry at least, with so many missions, deploying Starlink satellites and other missions. We've been waiting for a long time for a new company, like in the second generation of new space companies, to come along who may challenge SpaceX in that regard. Do you think Relativity has a chance at that?
Stephen, I do think that they have a chance here, and a meaningful one. And so the reason that I say that is that Starlink's success is a blessing and a curse for the company. The space industry, if you look at the way it has ordered launches in the past, and the way it's dealt with launch vehicles or launch vehicle providers is that it likes to have a selection of at least 3 players. So at the time when SpaceX was in its infancy with the Falcon 9, you essentially had a duopoly between the European Ariane program and the Russian Proton for commercial launches. So it was SES out of Luxembourg that really championed SpaceX and entrusted them with commercial satellite early, putting, I don't usually release the price tags on these, but it's safe to say that an GEO satellite usually costs at least $100 million. So you can call it $200 million bet on Starlink, or excuse me, not Starlink, on SpaceX and Falcon 9 back around 2014. And now they had 3, and that was great. And then Proton faltered. Its launch record, it endured too many failures. It became a vehicle that few were willing to trust. And then with recent events, geopolitical events, Russia has essentially cut itself out of the world market. And so now we're in this position again where SpaceX is the only company that is launching regularly, and the world is essentially compelled to use them if you want to get to orbit in any sort of timely manner. Every other new vehicle has incurred extensive delays, and none of them are flying at a high cadence. And even those that are flying aren't flying at a cadence that's remotely close to what the Falcon 9 is today. So I do believe that the industry is going to want, again, minimum 2, but likely 3 strong providers of heavy lift services. And at a time where that is in flux, we see a number of players jockeying for those spots. I think SpaceX is pretty secure where they're at. You've got the Ariane 6, and you've got the new entrant from Rocket Lab with Neutron. You've got Vulcan from ULA, you've got New Glenn, H3. You've got a large number, and add into that Relativity, which has come onto the scene really convincingly, even though they haven't really proven themselves in terms of a fully successful launch yet. But they've shown a willingness to push the boundaries, in a way that I think does resemble SpaceX. For SpaceX, the thing that they championed was reusability. And there was a great deal of skepticism about the viability of that as an approach. And they proved that it worked. Relativity's insistence that 3D printing can be a game changer on a similar level is something that I think has captivated the industry. And they want to see somebody who is going to continue to revolutionize launch, create lower launch prices, more versatile launch systems. And that gives them a chance to really be a big player. Not to mention the fact that they claim, Tim Ellis has claimed that they have upwards of $1.7 billion in launch commitments. Have to press them on whether those are firm contracts. I think startups like to talk about how many people have committed to their business, but whether or not that's binding, we'll see. But
Caleb,
in terms of, yes.
No, I was just going to jump in and just add one point. One advantage SpaceX had that I'm not sure Relativity has is they had an owner that's willing to risk virtually everything to make his product work. If you look back at the Falcon 1, when NASA gave SpaceX the contract for the cargo Dragons, they were basically one paycheck away from not being able to make payroll. But Elon Musk, and we could talk all day about what people think of Elon Musk. He was always willing to pretty much bet the company to make it work, and he didn't have to please anybody but himself. And I think that's a big advantage over most corporate people in the business. How much failure can you absorb and still be a player? And then the only other point I'd make, Relativity's had 1 flight, so I would agree there's certainly a thirst for competitors out there, but I think it's way too soon to weigh in on Relativity. They got to get some successful missions up before I'll think of them as a possible competitor, for what it's worth.
Yeah, it's interesting. It's going to be really interesting to see if Relativity does do another test flight of Terran 1 based on what they saw in the outcome of the flight last week. You know, because we heard from Tim Ellis before the launch that if they prove that 3D printing could survive those forces at max Q, at max aerodynamic pressure, and they had some sort of more, for lack of a better term, run-of-the-mill rocketry type failure, like an engine issue or something like that, or valve or whatever caused the second stage engine not to light, that they could elect just to move on to Terran R. And of course, they are a very well-funded company, one of the most well-funded of this new crop of new entrants in the launch business, and they have ambitions to go fully reusable down the road in a few years' time potentially. So, you know, that's a good point you raised, Bill. You know, they did not get to orbit on this flight, but did they learn enough? And Caleb, do you think they'll move on to Terran R? Or do you think they'll take another stab with Terran 1?
You know, I know that they are not going to stick with the Terran 1 for very long. It's not clear, like you said, how many missions they'll continue with it, but the movement, not just for Relativity, but for the global launch sector, is to scale up so that companies can support mega constellations.
Yeah,
that's what Relativity wants to do. And so that's what they're going to go after. I really think that the Terran 1 fits in a place for Relativity, not unlike what the Falcon 1 did for SpaceX. It's a proving ground for them to do a vehicle that can then address a much larger share of the market.
Yeah, I think that's a good point, Caleb. And the small launch business, the market size for that segment is pretty limited, and we've seen that be filled both with rideshare missions from SpaceX as well as companies like Rocket Lab, which is made at least a successful business with regular flights of the Electron in that very low class, small class launch market with, I think they're up to like 200 kilograms of up mass for Electron. Terran 1's bigger than that, but certainly not in the class of the Falcon 9 or Vulcan or Ariane 6 or some of the rockets Caleb mentioned earlier. That will come with Terran R down the road. Bill, moving on to another story that you had this week with the delay of Boeing's Starliner crew capsule. NASA and Boeing announced yesterday that the first crew flight with the Starliner won't be happening in late April, as they had previously said. Bill, what's the reason for the delay, and when can we expect to see Starliner fly with crew now?
Well, you know, one of the things about the commercial space program is when we get briefings, we don't get much in the way of detail anymore. So in terms of what's the delay, they claim they need to, review all the paperwork necessary for certification. They got a parachute issue they want to run one more test on the ground. But the details aren't really clear. What is known at this point, at least my understanding, if they're ready to fuel the service module of the Starliner spacecraft by June the 10th, they will have the range, the eastern range, for a launch attempt on July 21st. No earlier than. If they do not fuel the vehicle by June 10th, then there's a DoD Atlas mission that currently is on the range at the same time, and they will get that slot, and the Boeing flight will be delayed. So, I mean, based on what they told us this week, these are all solvable problems. They've got enough margin now to get it done, but we'll see. This is one that's almost impossible to predict. I was talking to a producer, and I mentioned this delay, and he said that spacecraft is cursed. And it almost seems that way, with the problems they've had with the unpiloted test flight. It's taken them a long time to get here. And obviously everybody wants them to get there safely, but it's going to remain to be seen if they can make this mid-July window.
Yeah, it's interesting to see because Boeing and SpaceX both received commercial crew contracts from NASA in 2014 on the same date. And those contracts covered the development of Crew Dragon and Starliner test flights as well. And then 6 operational missions each, crew rotation flights up to the International Space Station. And we just saw SpaceX launch their 6th under that original contract very early March. And once that crew comes back from the station this fall, those 6 missions will be done. Of course, SpaceX has an extension of contracts for more crew rotations up to the ISS from NASA beyond those 6. But SpaceX is going to wrap up that contract and move on to the extension before Boeing even executes. It's interesting to see that. Bill, what do you think is the reason for that?
It really is, and actually it was 7 launches to space station. One was a demonstration flight, of course, and they've launched 2 privately funded missions. So 9 flights of the Crew Dragon so far SpaceX has launched, and Boeing's launched 0. I remember back when these contracts were unveiled back in 2014, and I remember telling a friend, I said, well, I don't know about, how SpaceX is going to do. They were a new company. I said, but I don't have any doubt Boeing will get this thing going. Look at all the experience they've got. Without a doubt, they'll be able to do it. And look where we are. It's 9-0.
Yeah, we'll see if Boeing gets some points on the board this year with a successful, hopefully, a test flight with astronauts to the ISS. And I know Caleb, your expertise is in communications in many respects, but you have covered the commercial space industry before. Do you have any thoughts on the way companies like Boeing operate compared to the more nimble practices of a SpaceX-like company?
I feel like this is a long-standing rivalry that the two companies have. So in terms of civil space, it is a little bit less my domain. I think that a lot of people would have, certainly when the contracts were announced in 2014, it was it was the whole new space versus old space. People don't really like those terms anymore. Maybe never did actually, but that was really that was the argument that was being put forward. And again, 2014, Falcon 9 just beginning to fly. Dragon still proving itself. We've come such a long way where now Starlink, I keep saying Starlink. This is the name I hear all the time. It haunts me in my dreams now. But SpaceX is the one that now is like the incumbent. In many ways, I believe that they are NASA's second largest contractor, right after JPL. So to see that evolution is really something that it suggests to me SpaceX was significantly underestimated by their
without a doubt
peers. Yeah, and now that's starting to show. It reminds me a little bit of something I heard a while back, that people with imposter syndrome tend to do better than those without, because there's more of a sense of a need to prove that you can do it versus the person who walks in confidently, thinking that they've already got it in the bag. I wouldn't be surprised if some of that mentality was there, and it was this complacency that perhaps allowed SpaceX to pull ahead here. And it also brings me to, makes me wonder about the launch equation here too. This is something that, I guess I'm curious for you or Bill's take. Starliner is supposed to launch on Atlas, the Atlas vehicle. Atlas is on its way out. What happens if there are so many delays that Atlas is rendered inoperable? Is there a contingency plan?
That's a good question, Caleb. I think is there a contingency plan? Back in the very early days of Starliner, the Boeing team called it a rocket agnostic spacecraft. There were artist concepts of the Starliner flying on Falcon 9, even Delta 4. And I know the Boeing team is in discussions with ULA, I think early stage discussions about eventually transitioning off of the Atlas onto the Vulcan, human rating the Vulcan down the road. My understanding, though, is the contract that Boeing has with ULA, ULA has set aside Atlas boosters for those particular Starliner missions, those 6 missions that are on contract. So I could foresee a scenario where in the late 2020s, when Boeing is still executing on this commercial crew contract, where ULA has flown out all of their Atlas V missions for Kuiper and for DoD, but they're still launching maybe one a year for Starliner on missions to the ISS, keeping that Atlas infrastructure alive for another 7-8 years, potentially through the very late stages of the space station lifetime. Or they could transition off of Atlas to Vulcan if Vulcan proves reliable and cost-effective. Bill, do you have anything to add?
No, I would agree with what you said. That's my sense of what their long-range plan is. But I just wanted to back up 1 second. We were talking about, Caleb was talking about the, difference between Boeing and SpaceX. I get a real sense of a bureaucracy, for lack of a better word, at Boeing that you don't get that sense at SpaceX. And the other thing about Boeing is they're a shareholder-driven company. You know, they will not go out and risk vast sums of money in the same way that SpaceX has shown a willingness to do. And I'm only saying that because I just think it's a factor in all this. I don't know how big of a factor, but they have such different management styles. It's really hard to compare. I guess that's all I'm saying. Caleb, you probably know more about this than I do.
I mean, for me, the concern that this conversation brings up is it makes me wonder if Atlas 5 is flying at a really low flight rate in the late 2020s. You know, there's knowledge that gets lost, you know, as vehicles change. And
Yep.
actually, one of the reasons that people transition from an old rocket to a new one is because of the talent that built it and understands how to use it, you know, ages out. You know, ULA has a stellar reputation with Atlas 5. I'm sure they would do everything they can to maintain that with the vehicle, you know, right through to its conclusion. But it's not something that, to me, engenders a lot of you know, feelings of security, knowing that they're going to have to prolong the life of a legacy vehicle where the skills that are the skill set that exists today to operationalize and fly that vehicle on a regular basis will be faded, you know, by the time that vehicle is flying. If it's 2029, 2030, or what have you, you know, there's an
Yeah.
element of risk there.
And don't forget, they've lost hands-on Russian support for the RD-180 engine in the wake of the Ukraine invasion.
Yeah.
Yes. Yeah. So the knowledge of that engine, ULA has some of the hands-on knowledge from the Russian manufacturers already lost access to that. So that's a good point, Bill. And another thing I just thought of right now was a lot of us may forget this, but like 3 or 4 years ago during Starliner development, I think before the first test flight in 2019, one of the issues they encountered was aerodynamics. Putting the capsule on top of the Atlas V, they had to add an aerodynamic skirt kind of late in the process under the spacecraft
Right.
because the aerodynamics weren't as they expected in some wind tunnel testing and some computer modeling. So if they moved the spacecraft to Vulcan or another rocket, if Atlas became unavailable, you know, that they've already encountered aero issues integrating with Atlas. Would they encounter similar issues integrating a capsule of that shape onto Vulcan or Falcon 9 or something else if they had to? So
yeah, I'm sure they already have some data along those lines. I'm sure they've been modeling such things over the last couple of years, but I don't know what the answer is to that one.
Yeah, it'll be interesting to see how. Go ahead, Caleb. I think you have something to say.
Oh, I was just going to say it makes me curious if some of the new entrants that are designing crew-capable vehicles, crew-capable launch systems, are factoring in CST-100 and Starliner. Like you probably remember better than me, or both of you remember better than me, who is doing that. I think Relativity, because of their Mars ambitions, will likely make a crew-rated design for Terran R, maybe Neutron. Would be very interesting to see if those vehicles, you know, look at Starliner as an opportunity, are looking at future commercial space stations, servicing those as an opportunity, and what that presents in terms of options for Boeing as the Atlas vehicle retires.
Wouldn't New Glenn be a player in that sort of thinking, or not?
Yeah, they could. Yeah, I think their vehicle is so much bigger. I wonder if it.
Well,
I don't know what the terms are, like the radius. I know they've got like this significantly larger payload fairing than
yeah,
everybody else. It makes me wonder how something like Starliner would fit on top of it. But the launch market is a small one, so I'm sure that the folks at Blue Origin are thinking of every way to maximize their total addressable market, and if that includes Starliner, I'm sure they'll look at ways to make that work.
Yeah.
Well, I want to move the conversation along a bit before we run out of time. Some breaking news just last night from United Launch Alliance on the Vulcan rocket that we've been talking about in the last few minutes. Tori Bruno, the the CEO of ULA, mentioned on Twitter last night that there was an issue, an anomaly encountered during some qualification testing of the Centaur upper stage. This is the enlarged Centaur 5, which has a wider diameter and and 2 engines versus 1 engine that's flown on the Centaur that flies on the Atlas V. Had some anomaly during some testing, some qualification testing. Remains to be seen what the impact of this might be on the launch date for the first Vulcan. The most recent update from ULA about a month ago now indicated the company was targeting around May the 4th for the first test flight of Vulcan. So engineers will be, of course, looking at this test result on the Centaur 5. They're also undergoing some tanking tests with the Vulcan in the recent weeks here at Cape Canaveral, all leading up to a test firing or static fire of the Vulcan first stage with these new Blue Origin BE-4 engines, also fueled by methane, much like the Terran 1 rocket we talked about a few minutes ago. So it'll be interesting to see how this Vulcan rocket's test flight, how the schedule moves based on this Centaur qualification test, based on the progress of the tanking test operations here at the Cape. And, Bill, what are your impressions of how close ULA is to flying this rocket, and just your thoughts on Troy Bruno's update from last night?
Well, my less than technical answer is, as you point out, this came out in a late night tweet, used the word anomaly with no details and said, we'll keep you posted. And that never, ever sounds good. Okay. So, this sounds like this was a significant event of some kind. We hadn't heard any details yet. But we're just going to have to wait and see. I don't have any way to read this one until ULA gives us a little bit more information.
Yeah, in many ways, the Centaur 5, it's a new upper stage. I mentioned it's a bigger structure than the Centaur that flies on the Atlas V rocket, has 2 engines versus 1, but it is based on a long heritage of Centaur upper stages that have flown since the 1960s. In many ways, on the Vulcan, the new secret sauce, so to speak, is the first stage with the new methane-fueled engines from BE-4, U.S.-sourced engines replacing the Russian engines on Atlas V. So, not entirely expected that this would be where the issue is. That a lot of the delays with Vulcan so far have been on the first stage.
Yeah, but the problem with even talking about this at all is we don't have any idea what system was involved or what failed. And until you get that kind of information, I mean, there's no way to even make a guess. This could be something very minor, or it could be a real setback. I mean, we just got to have more detail to have any kind of an informed opinion.
Yeah, I think
go ahead, Caleb.
No, just kind of echoing what you said earlier, just the Centaur 5, if we remember, was a replacement for ACES, which is supposed to be a really advanced upper stage that could even stay in orbit for years afterwards and perform additional complex missions. So I do think it was a surprise to see an anomaly here.
Yeah, for sure.
That was supposed to be more stable, more legacy, more conservative. It's good that you find it in testing rather than on the launch day. So I think that is something that should be celebrated. But they're obviously going to need to take their time and treat this again as a new system and make sure that it performs up to spec.
Yeah, and obviously, Caleb, I totally agree with that. I mean, you want them to find it on the ground and not in flight. All I was trying to say was that we just don't have enough information other than the word anomaly to have any clue as to how significant it might be in terms of their process.
Exactly. And just for our listeners, qualification testing is usually a phase in testing where engineers check the performance of the structures and components that they built compared to the design spec. So this is a testing that they do before maiden flights of rockets, and then once there's a production of rockets, a steady cadence of hardware coming out of the factory, they do what's called acceptance testing, where they make sure that the individual components and hardware coming from the factory are built according to process. So again, this is part of the late stage development of Vulcan. We're seeing the first Vulcan on the pad undergoing some testing, but all of the qualification effort and all that testing behind the scenes that we're not seeing out at the launch pad on the test stand still underway in parallel. So obviously still a bit of runway ahead for ULA before they get to their first Vulcan flight. The last thing I wanted to talk about today was an announcement coming on Monday, which will be the announcement of the Artemis 2 crew. These will be the first astronauts to fly around the moon since 1972, more than 50 years. This follows on the heels of the Artemis 1 unpiloted test flight with the Space Launch System and the Orion spacecraft late last year. Bill, can you give us a preview of what this announcement is going to be like on Monday?
Well, they're gonna make a major show out of it. I can tell you that for the publicity value. They're going to name 4 astronauts to fly the food. It's almost certainly going to be an international crew. A lot of speculation that Jeremy Hansen, the Canadian astronaut, will be part of that crew, but that's just speculation. There will almost certainly be a female astronaut and perhaps a person of color. And beyond that, we don't really know. We're going to have to wait till they tell us who these people are. The flight itself is kind of interesting. You know, people keep comparing it to Apollo 8 or something, but it really isn't. If you remember, Apollo 8 went to the moon. They, I think, did 10 orbits or whatever before they broke out of orbit and came home. This flight is more of a shakedown mission for the Orion capsule, with the full life support systems being implemented. They're going to take a long looping orbit around the Earth and check out a lot of those systems, and then they're going to use the Orion's thrusters, the service module thrusters, to send them out beyond the moon and back. They're not going to orbit the moon. It's a free return trajectory. So they're going to go out beyond the moon, circle it, and come back and splash down in the Pacific Ocean again, just to flight test all those life support systems that are going to have to work down the road for the Artemis program. So it's a relatively straightforward mission. This will be the first crew to ride on top of a Space Launch System SLS rocket, currently the most powerful rocket in the world, although you guys both know SpaceX has an even bigger rocket waiting in the wings ready to go pretty soon with their Starship mission spacecraft. But it'll be an exciting mission. As you say, it's the first time anybody's gone out beyond the moon since Apollo 17 came home back in 1972. So I think it's something that's going to generate a lot of interest. And the first step, of course, is putting that crew and naming that crew. And I sort of have some sympathy for them because I think they're going to end up doing an awful lot of interviews between now and launch.
I can't wait to see who's going to be on this mission and, you know, whose names will be on the tips of the tongues of many Americans and many people around the world probably when they do fly. Bill, what's the schedule for Artemis 2? When is that supposed to launch?
Well, that's Stephen, at some point before today's session is over, you have to ask me a question that I have an answer for because I don't. The best guess right now, and pardon me while I wave my hands and turn the lights on back in here. The best guess right now is December 2024. I'd be surprised if they make that. If anybody who's followed the SLS program knows, they don't make their dates with any regularity. I mean, they may be able to do it. We'll see. But certainly by if not the end of 2024, early in 2025. And then, of course, that sets the stage for Artemis 3, which is to send 2 people to the surface of the moon near the South Pole. So this is a Pathfinder mission, I think, in a sense. But just, you know, putting people on that SLS rocket and sending them out beyond the moon is going to be a significant milestone for NASA, no question.
You mentioned Artemis 3, Bill, and the landing attempt on the South Pole of the moon after Artemis 2 is probably still several years away at best. At best. The lander for that system is SpaceX's Starship, which you also mentioned, which is readying for its first test flight, first orbital test launch attempt, perhaps in the coming weeks, maybe coming months. Right now, probably no earlier than late April, but that's the latest just from Elon Musk. We'll see if that holds. But we've seen the booster with the 33 Raptor engines put on its launch pedestal again yesterday for, if everything goes according to plan, in the upcoming test, perhaps the final time before that test launch. And here's a view now from Starbase in South Texas. Bill, how big of a deal will this launch be? You know, we saw Artemis 1 with the Space Launch System get a lot of attention. Artemis 2, I'm sure, will get even more, you know, put Artemis 1 to bed in terms of media attention. The Starship rocket won't have anybody on board, but it has the key to a lot of NASA's future exploration plans in it. Can you talk about that test flight coming up?
Yeah, it really does. You know, and you know, we all made a big deal out of the SLS rocket being the most powerful operational rocket in the world. The space launch, the super heavy Starship really dwarfs that. You know, they're talking 16 million pounds of thrust at liftoff. I mean, even the Russians' old N1 moon rocket, which they never successfully flew to orbit, its max thrust was something like, I guess, 10 million pounds coming off the pad or close to that, something like that. This rocket's going to dwarf anything that's ever flown before. And I think, when you think of the Starship, that's the vehicle NASA is paying to have a variant of that be the moon lander for the Artemis 3 mission. That is I don't want to say I'm a skeptic, because I think people who sell SpaceX short have tend to be surprised. As Caleb was talking earlier, they get underestimated. But when you're talking to get to the moon for that flight, Stephen, you're talking about refueling that Starship in orbit with thousands of gallons of cryogenic propellants multiple times to be able to go to the moon. I mean, the numbers we keep hearing is 4 refueling flights before it can even go to the moon. This is all technology that's never been demonstrated in Earth orbit. And I guess the rocket is so big. It's in so much propellant is required for each launch. It all has to go well. All those engines. It's going to be a challenge. And I think even for SpaceX, it's going to be a challenge to make that work. I'm not saying they can't. I'm just saying nobody's ever attempted anything even remotely like this before. So it's going to be a lot of fun to sit here on the sidelines and see how they do. It's going to be exciting, no question about it.
And it's fully designed to be fully reusable, fully recoverable, both stages of the Starship. If Elon Musk's dream and ambition for Starship even comes close to reality, it will be a game changer in the launch business, not withstanding the lunar flights. Caleb, what are your thoughts about potential future commercial use in the global market for Starship?
Yeah, so the vehicle is interesting because SpaceX is continuing to fly Falcon 9 and Falcon Heavy while also developing this new system that, as Bill said, is just so much bigger than anything that's flown before. And to me, the most interesting thing is the promised reduction in launch price. I think I'm blanking on actually the figure that Elon has stated in terms of price per kilogram, but it's significantly lower than the current, the prevailing launch rate. And so the industry has talked a lot about how lower prices has made more opportunity for the space industry to grow. But I really think that just as much credit goes to Moore's law and the miniaturization of electronics. It was equally the fact that you could make the spacecraft smaller, and in that way you could lower your launch price. And then layer on top of that, you got some lower cost from SpaceX and the competitive pressure that they put on their peers. But what SpaceX is offering to do with Starship is bring down another order of magnitude, or an order of magnitude at least, reduction in price for customers, and that allows people to start to really dream differently about what they could do in space. So some of the early examples, telescopes are a big one. Look at the James Webb Space Telescope and how that was folded up inside the payload fairing for the Ariane 5. It was basically an origami telescope. You had to get it so that it would fit inside the payload fairing. It was volume constraint. With Starship, you could build really big telescopes that you don't have to, bottle up and compress. You can just fly it as is. For communication satellites or even big imaging satellites, you can change the game because you can have much bigger satellites or launch whole swarms of smaller satellites. And we're starting to see some technology there. There's a company called K2 Space that is preparing satellites that would be, I want to say, anywhere from like 10 to 25,000 kilograms, and that's just huge compared to the biggest spacecraft today, excluding whatever the NRO or secret agencies are doing. They usually max out somewhere between 6,000 and 7,000 kilograms, with the occasional spacecraft that climbs above that. So we could see some really radical new designs in terms of spacecraft. And then the even bigger wild card is what kind of in-space economy will this enable? Do commercial space stations become more attainable Does it become feasible to return things from space? I personally would love to see us return Hubble, bring it back, not burn it up in the atmosphere. I'm sure other people are going to float interesting ideas for what to do with a reusable second stage. And then the last comment that I would make is just wondering, what sense does it make? I think I talked here a lot about the opportunity that comes with a bigger vehicle. I'm wondering, I guess, a little bit if there's an upper bound for how much people can actually make use of the vehicle. I think in aviation, I'm not an aviation guy, but my understanding is that there are some aircraft that were built bigger than what the market would accommodate. Actually, I flew one of those back from India. I think it was the Airbus A380 that had like a double decker situation going on, and they just kind of cordoned off the top floor because no one was using it. Because the whole idea of tons and tons of expensive seats didn't work for them. So I think there are limited examples where somebody tries to go bigger. I think the lower they can bring the cost, the more they can make use of it. So it's really going to hinge on what kind of price tag they can ultimately sell the vehicle for.
Yeah, you know what, Caleb, I was just thinking your very first point was cost, and that's your last point, and I totally agree with that. If they really can get the cost down like they talk they can with super heavy Starship, I mean that will guarantee an audience. I think it'll guarantee a customer base if you can put things into orbit less expensively. My only question about Starship and super heavy is, can they make it work? I mean, I just think this is just a gigantic technological challenge, and I certainly wish them the best, but I think it is a challenge, and it's going to be interesting to see how that plays out.
Bill, do you see any parallels between what maybe NASA promised with the space shuttle and the ambition that Elon Musk and SpaceX have with Starship? Obviously, they have the benefit of not having the government bureaucracy or the Air Force levying requirements onto them.
Well, there's one major difference in those two things. If you remember, they used to try to sell the space shuttle as, we'll fly this thing, twice a month, 25 times a year or more. That was political from the day one, and they're trying to get money from Congress and make it attractive to Congress to fund that program. That's not what SpaceX has done here. I mean, the SpaceX decision to build super heavy Starship is theirs because of what they see coming down the road, not what they're trying to convince somebody they can do. So I see that as apples and oranges. I will say for Elon, he clearly has a vision. He thinks he can make this work. Maybe I should say Gwen Shotwell thinks she can make this work, since Elon's tied up with other things right now, it seems. But seriously, I mean, like Caleb said, nobody's ever tried anything like this before, but it's a purely SpaceX project, and it's on them to make it happen. And I wish them luck. We'll see.
Yeah, I'll add that I think it's novel that SpaceX continually sets the bar for themselves. I feel like this is a difference in how vehicle evolution has occurred in the past. It was very government driven, and you can look around the new vehicles that are coming up. Ariane 6, the motivations for that. H3 motivations for that. ULA, Vulcan. It was always a different catalyst. It wasn't just we want to overhaul the launch business. We want to make something so much drastically better that we put our old product out of business. That's what they're trying to do here, and they have forced the rest of the industry to play along in this race. Now, it wasn't always this competitive, but they've made it that way. And so I hope that not only does it inspire the industry in terms of people who will get to use rockets, but that it'll continue to inspire other launch providers to keep pushing the envelope and make more systems that can open up space for all.
Amen. Yep.
Yep, Caleb, Bill, we've run over time a little bit, but I wanted to keep the conversation going because it was interesting, and we appreciate having you both on our roundtable today with Spaceflight Now. And for those of you, just a reminder, Bill Harwood is the space consultant for CBS News based at Kennedy Space Center. Caleb Henry is Director of Research at Quilty Analytics and a former space reporter. Thank you both for your time, and we hope to have you join us again.
Be my pleasure.
Happy to be here.